Hi, welcome to my channel pibyme Maths. This is Lesson1. Here we are going to start chapter 3 Vectors in Mechanics. 3.1 Working with Vectors. Okay, these two topics, if you have already learned P4 vectors, it's the same thing. Or let's say you are learning M1 first, then whatever you are learning here is going to be the same in P4 vectors also. Plus there are a lot of other things to learn also in P4. Okay, first I'm going to explain these vectors now. Let's say I'm saying a car is traveling at 20 meter per second. Do we really know in what direction the car is traveling? No, right? Unless it's specified. But if I say the car is traveling 20 meter per second east, we know the car is traveling in this direction, right? So scalar, the first one is scalar without the direction. So the scalar gives us just the magnitude. The vector gives us the magnitude and the direction. So this examples like mass. We say, let's say 5 kilogram, it has no direction. Time, 10 seconds, no direction. Distance, 20 meter, no direction. These are all scalar quantities. For vector quantities, let's say velocity, we need this with the direction. Or displacement, or acceleration. These are all some examples of vector quantities. So in scalar you don't need to worry about the direction, but in vector we have to mention the direction. We need to know in which direction, right? So now let's say a student is traveling, starting to walk from point A to point B, 5 meter. And then she comes back to point A. The total distance she traveled is 5 plus 5 is 10 meter. But the displacement, she is at the same place where she started now. So the displacement is 0. Because this is positive 5, this is negative 5. So when you add, the displacement is 0. So that's why when we mention vector from A to B, we put an arrow on top of it, AB vector. Here AB vector is 5, but B to A vector, BA vector is minus 5. In general, if you take AB vector as A, small a, the BA vector will be minus A. And then the magnitude of the vector is the distance. For example, AB, the magnitude, we put a modulus AB vector. That's just A. How about modulus BA vector? Modulus BA vector is also the magnitude. The distance, it's just A. Don't put minus A, it's just still A. The modulus of both these vectors are same. Modulus is just like, consider it like a length of this line. It's same irrespective of the direction, right? And the next thing you should know is when we take the two-dimension plane x and y axis, from origin, if you go 1 unit to the left, that's I. It's denoted by I. If you're going this direction, if you're going left side 1 unit, it's gonna be minus I. If you're going upward direction 1 unit, that's J. Downwards is minus J. So when we denote a vector, we are gonna use this I and J to denote a vector. For example, here I have taken a grid here. Let's say you are given AB vector is equal to, let's say A is here. AB vector is 3I plus 2J. So you need to go 3 units positive direction, 1, 2, 3, and 2 units upwards in the y direction. So this is going to be AB vector. Let's say from B, BC vector is 2i minus 3j. So from B, you need to go 2 units to the right side, 3 units downwards because minus 3, 1, 2, 3. That's going to be the BC vector. That's BC vector. So if they ask you to find AC vector, you can simply add this to AB vector plus BC vector. So when you add them, add the like terms, 2 plus 3, 3 plus 2, 5y minus j. Okay, let's start from A. We are going to go 5 units to the right. 1, 2, 3, 4, 5, 1 unit down. So you will reach AC vector. That's AC vector. Hope you understand this. So you can write this vector using I and j, or you can write this using column matrix. Just put a bracket, a long bracket, write 3, don't put ij, just put the numbers 3, 2. For BC, it's 2 minus 3. For AC, it's 5 minus 1. Both are correct. This also correct, this also correct. The first one using I and j, the second one using column matrix. That's how we denote the vectors. So let's look at some questions from this exercise, exercise 3a. Question number 1. A bird flies 5 km due to north. So this is 5 km. And then 7 km due east. This is 7 km. How far is a bird from its original position? So you need to find this distance. Since it's a right angle triangle, you can use Pythagoras theorem. So let's call it O, A, P. So OB is square root of 5 square plus 7 square. Square root of 5 square plus 7 square. So 8.60 kilometer. She is 8.60 kilometer far from the original position. It's a simple question. Oh, sorry, they're asking direction also. Okay, I need to explain this first before I solve this question. Let me take a vector here. Okay, let's say this vector. This is 3 units, this is 2 units. So AB vector is basically AB vector is 3i plus 2j. If you want to find the magnitude of the vector, that's basically the length of the vector, you can complete this right angle triangle, use Pythagoras theorem, which is square root of 3 square plus 2 square. 9 plus 4 square root of 13, right? To find the direction, you need to know the angle that the vector makes with the positive x-axis. If I extend this line, this angle is going to be same as this angle, right? Because these two are parallel lines, correct? So how do we find this angle? We use SOHCAHTOA. So tan theta is 2 over 3. So you can find theta tan inverse of 2 over 3. So we have learned bearing before. The angle that the vector makes from the north direction. That's what we need. If we know theta, we can subtract from 90. This whole angle is 90, right? So you will get this angle. So you can say on a bearing of, you find pi minus, okay, 90 minus, I'm going to put it in degree mode, 90 minus tan inverse of 2 over 3. 56.3 on a bearing of 56.3 degree. But when we write the bearing, we need to write the 056. 3 digits actually. Okay, anyway, back to this question now. The question clearly says, how far from its original position, that's 8.6 kilometer, in what direction? So since this is north direction, we need to find this is the bearing, right? So you can find tan theta is 7/5. Theta is tan inverse of 7/5. Tan inverse of 7/5. That's 54,054 degree to the nearest degree on a bearing of this. So we need the distance and the bearing also to mention the direction. Let's look at question number 2 now. A girl cycles 4 kilometer due west. Okay, 4 kilometer due west. 4 kilometer. And then 6 kilometer due north. 6 kilometer due north. From O, she goes to A and then to B. Calculate the total distance she has cycled. They're talking about total distance actually, which is 4 plus 6 is 10 kilometer. That's not the displacement, that's a distance. If they are talking about displacement, this is the displacement from O to B. So OB is square root of 6 square plus 4 square. So square root of 6 square plus 4 square. 7.21 kilometer from the starting point. That's her displacement. The distance is 10, but the displacement is 7.21. Now let's look at question number 3. Express the vectors v1, v2, v3, v4, v5 and v6 using ij notation. Look at v1. Okay, this actually 2 squares are 1 unit. Always remember this actually. Okay, in this case, so you need to pay attention to the unit given. So it's 1, 2, 3, 4 on the positive axis, so v positive x-axis, so v1 is just 4i. v2 now, v2 from here, starting here, 1, 2, 3, 4, 5 units, so 5i plus 1, 2 units up, so it's 2j. Let's look at v3 now. v3, 1, 2, 3 units right side, 1 unit down, so 3i minus j. But you need to pay attention to the direction. What we calculated is starting from here, let's say this is A and this is B. What we have here is AB vector, but we need BA vector, right? So basically we need to start from B actually. We need to start from B and reach A. So it's basically 1, 2, 3 units to the left, 1 unit up. So it has to be minus 3i plus j. That's very important. Okay, now the next one, v4. v4 this direction, so 1, 2 units to the right, 1, 2, 3 units to the top, 2i plus 3j. v5 now, this direction, so start from here, 1 unit down, start from the x-axis, 1, 2 units to the left, 1 unit down, so minus 2i minus j. v6 now, 1, 2, just 3 units down, so it's just minus 3j. That's all. So when they ask you to add, just add the like terms. For example, v1 plus v2, you add these two, you'll get 9i plus 2j. Just add. It's just like a normal addition. When it comes to addition and subtraction, it's like normal addition and subtraction. Add or subtract the like terms. Find the magnitude of each of these vectors. So for part A, first one, the magnitude, we are going to apply the Pythagoras theorem. Just put 3 square plus 4 square, which is 9 plus 16, 25 is 5. That's all. That's how you find the magnitude. No matter the direction. For example, H, just put square root of 4 square plus 1 square, the coefficient 16, square root of 70. So for G, just write modulus 3i plus 5j, that's the magnitude, and then you can write this step. 3 square plus 5 square. So 25 plus 9 is 34, square root of 34. That's how you find the magnitude. If they want you to change it to decimal, change it to decimal. Now you are given 3 vectors A, B, C. Find the exact magnitude of the below vectors. For A, first find A plus B. A is 2i plus 3j plus B is 3i minus 4j. So you're going to get 2 plus 3. Simplify the like terms. 5i, 3 minus 4 minus j. So modulus A plus B is square root of 5 square plus 1 square is square root of 26. That's all. First find the vector and then find the modulus. For example, C. 3b, 3 times, okay, 3b minus 2c is 3 times b minus 2 times c. So it's going to be 9i minus 12j minus 10i plus 2j. So you're going to get minus i minus 10j. So the modulus of 3b minus 2c is square root of 1 square plus 10 square is square root of 101. Question number 6 now. Find the angle that each of these vectors makes with the positive x-axis. Okay. If you take this vector 3i plus 4j, this is 3 units and then this is 4 units. They are talking about this vector, right? This vector. So let's say x-axis is here, the angle will be this theta. So for A, you can just write tan theta is equal to 4 over 3, find theta, tan inverse of 4 over 3. Now for B, 6i minus 8j. So let's say this is 6i minus 8j, so downwards 8. This is the vector. Now let's say x-axis is here. The angle is this angle. So tan theta is 8 over 6. Theta is tan inverse of 8 over 6, but below x-axis. Right? For the first one, it's tan inverse of 4 over 3. That's 53.1 degree above x-axis. Here, tan inverse of 8 over 6. Okay. That's also 53.1, but it's 53.1 degree below. Now let's take one more question, 7a. 3i minus 5j. Find the angle that it makes with the positive y-axis. Okay, 3i minus 5j. We are talking about this vector. This is 3, 5. So the y-axis is here. So let's put the y-axis here. They want this whole angle actually. We know this angle is pi over 2. We need to find this theta. So the angle that the vector makes with the positive y-axis will be pi over 2 or 90 degree plus tan inverse of 5 over 3. So you will get this angle. You need to add both actually. That would be the angle. 5 over 3 plus 90. That's 149 degree. But 149 degree to the right. To the right. Let's take one more, D. That's minus 4i. Okay, let's say our y-axis is here. It's minus 4i minus j. This is 1. We are talking about this vector. So to find the angle, you have 90 degree here plus this theta. So for D, it's 90 degree plus tan inverse of 1 over 4. 90 plus tan inverse of 1 over 4. That's 104 degree to the left. 104 degree to the left. That's all. We have completed 3.1 already. Let's look at 3.2. Solving problems with vector written using I and j notation. They want you to find in terms of I and j, just an easy one. For example, E 3a minus 2b is 3 times, write the a vector, 2i plus 3j minus 2b, 4i minus j, open the bracket and simplify the like term, 6i plus 9j minus 8i plus 2j, 6 minus 8, 9 plus 2 is 11j. That's all. So it's the same thing for the rest of the question. For example, I'll do one more, H 2a minus 3b, which is 2 times a minus 3 times b. So it's going to be 4i plus 6j minus 12i plus 3j. 4 minus 12 and then 6 plus 3 is 9j. That's all. Let's look at one more question. Before I explain this question, you need to understand something. Let's say you have a vector. This is AB vector. A. If there is another vector, let's say CD, the direction can be CD or DZ, doesn't matter. But for these two vectors to be parallel, one vector should be a scalar multiplication of another vector. What do I mean by that? If this is A, this should be some number times A. Or we can take another vector here, EF vector. That's 1 over 2a. The number can be a fraction also. So for two vectors to be parallel, there should be a scalar multiplication of each other. So how do we write that in general? If one vector is A, another vector is B, you can write A is equal to lambda B or mu B. We will be using all these Greek letters. Lambda, this is mu. So this is a condition for two vectors A and B to be parallel vectors. Now in this question you have A and B. A plus lambda B is parallel to I vector. So I can write A plus lambda B, this is the first vector, is equal to mu times I, because that's a condition for these two vectors to be parallel, right? A plus lambda B, write A, 2 plus 5j plus lambda times 3i minus j is equal to mu I. Simplify the I term, so you'll get 2 plus 3 lambda I, 5 minus lambda j is equal to mu I. So if two vectors are equal, the I component and the j component, the coefficient should be equal also. So here there is no j actually. So take it as 0j and equate them. 5 minus lambda is 0, lambda is equal to 5. That's how you find the value of lambda. That's for question A. We can do the same thing for question B now. The first vector mu A is 2i plus 5j plus B 3i minus j. This vector is parallel to j. So I can write it as a scalar multiplication. They use mu already, so I'm using lambda. In this case, first question, they use lambda, so I have used mu here. Open the bracket and simplify the I coefficients of I. 2 mu plus 3i. 5 mu minus 1j is equal to lambda j. There is no I here, so that means 0i. So equate this to 0. 2 mu plus 3 is 0. Mu is minus 3 over 2. Question number 4. In this question, the horizontal unit vector I and j are directed due east and north, respectively. Find the magnitude and bearing of these vectors. For the first one, A, it's basically 2i to the east, 3j to the north. So this is the vector. This is the vector 2 and 3, right? But the bearing is the angle that the vector makes with the north direction, this angle, right? So we are going to find the inside angle first and subtract from 90. First, magnitude, modulus 2i plus 3j is square root of 2 square plus 3 square. Which is 4 plus 9, square root of 13 is the magnitude. Unless they want you to change it to a decimal, otherwise keep it as it is. Now the bearing. Bearing is 90 minus this interior angle. Tan inverse of 3 over 2. So 90 minus tan inverse of 3 over 2. 33.6, take it as 34, so the bearing is 034 degree. I'll show you one more question. For example, D. Minus 2i, this is minus 2i. Let's say the y-axis or the north is here. Minus 2i minus j. This is 1. So this is the vector. So the modulus minus 2i minus j, the magnitude is square root of 2 square plus 1 square is square root of 5. Now the angle that it makes with the vector, you need to take the positive direction. So this angle is 270 minus this vector, this angle. That will give you the angle from north to the vector, right? So the bearing is 270 degree minus tan inverse of 1 over 2. So 270 degree minus tan inverse of 1 over 2. 243 degree to the nearest degree. 243 degree. That's all.